In addition to graphical and verbal descriptions, we can use numbers to summarize quantitative distributions. Suppose we want to know what an average value is, so where the data is centered. Another thing to consider is also how spread out the values are. This is the measure of variation. Consider these three sets of quiz scores for a 10-point quiz. Section A, all 10 scores were 5 points. In Section B, 5 of the scores were 0 points and 5 of the scores were 10 points. In Section C, 3 of the scores were 4 points, 4 of the scores were 5 points, and 3 of the scores were 6 points. All of these sections have a mean and median of 5, but that doesn't really give us a good idea about how spread out these values are, because Section A is clearly had very different types of scores than Section B. So this is where, in addition to mean and median, having those measures of center or the average values really helps us get a picture of how spread out these data values are. So one way to measure a variation is by using what's called the sample standard deviation. The sample standard deviation S is a measure of variation that tells us how far, on average, the data values deviate or are different from the mean. The mean and standard deviation are paired, and they're paired so that we have a measure of center and a measure of variation or spread for symmetric distribution. So when you have a symmetric distribution, typically using the mean and the standard deviation is what is the best route to use for how the measure of center and the measure of variation or spread. Now, you can use Desmos or Excel or Google Sheets for finding the standard deviation. I'm going to end up showing you examples of how I put it into Desmos, but with Desmos you just type in STDEV and then parentheses, and then you list out the numbers with a comma in between. In Excel, it's using the equals stdev.s, and then you list the numbers again with commas in between. So if I found the standard deviation of section A, and again, you can see this is using Desmos, this is a screenshot from Desmos using that stdev function, I get the standard deviation is 0, and that's because these don't vary at all. All of these scores are the same value. I would assume when I find the standard deviation in section B, those vary quite a bit, going from 0 to 10. So that's going to be a higher variation, and let's see what we get. Yeah, that's definitely a lot higher. So the standard deviation is 5.27. Now in section C, we're going to assume these values are they're not like section A where they're all the same. But they're not like section B where they're wildly different where you're going from 0 to 10. They're clustered pretty similarly. So I would expect that standard deviation to be lower than section B, but higher than section A. Because in section C, they're less spread out than section B, but they're more spread out from section A. So when you find that standard deviation, you get 0.816. Let's look at an example. The bar graph shows gasoline prices for unleaded regular gas. Find the mean, median, and standard deviation for the gasoline prices over time. And these are all real values. So looking through here, we can see in 1990, the price per gallon was $1.17. In 2000, the price per gallon was $1.52. In 2010, the price per gallon was $2.79. In 2020, the price per gallon was $2.08. And in 2022, the price per gallon was $4.60. So we had a huge spike in 2022. So if I wanted to go through and find the mean, median, and standard deviation, I'm going to use Desmos for this. So when I type this into Desmos, we use the mean function, and then you just type in each of the values for the price. And when we do that, we get a mean of $2.43. When I find the median, I'm getting also a value of around $2, so $2.08 for the median. Now when I find the standard deviation, that's $1.36. And that's because we can see, even though from 1990 to 2020, those values aren't spread out that much, this $4.60 really ends up making these values spread out. So that's why that's a little higher. Now, if I didn't include this value in the standard deviation, it would be lower because these are pretty closely, the variation isn't very high between $1.17 and the highest is $2.79 versus the smallest being $1.17 and the largest being $4.60. So if I took out this $4.60 from the standard deviation, I get only 71 cents. So again, because 4.6 is such a huge outlier, it's really pulling that mean to the right, and it's pulling that standard deviation further away from that mean than the other prices are, which is what's creating that standard deviation to be higher.